Hi, today we're looking at Pearson Edexcel Functional Skills Maths Level 2. This is set 7 and we're starting with the non-calculator section. Question 1. Here is some data. So we've got some numbers here, 146, 97 and so on. Find the mode of this data. Okay, so the mode means the one that occurs the most. So we can just look at the data or we can put it in order. Sometimes if we're trying to find the median, it's handy to put them in order and you can spot the mode. What I'm going to do something slightly different. And I'm actually going to write the numbers out. So we've got 146. But I'm going to see how many times have we got 146. What's once? Twice. So we've got 2 of those. Next number we've got is 97. We've got 1, 2, 3 of those. Next number is 109. We've got 1, just 1 of those. Then we've got 141. So we've got 1 of those. That's it. And then 103. We've just got 1 of them. Then we've got 94. And we've got 1, 2 of those. Okay, and if we want to do a check, we can see how many we've got in total. 2 plus 3 is 5, 6, 7, 8, 9, 10. And we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, great. Now we just need to see the one that occurred the most. 3 is the biggest number, so the mode is not 3, but is 97. Okay, part B. Work out 17.456 minus 6.072. So I'm going to write these on top of each other, lining them up. So we've got the units above the units, decimal points lined up. We've got the 0.72. And it's a subtraction. So 6 minus 2 is 4. 5 minus 7, well 7's more than 5. So we're going to have to take 1 from the 4, put it over here, and that means we're going to reduce the 4 down to 3. So now we've got 15 minus 7, which is 8. 3 minus 0, which is still 3. Bring down the decimal point. 7 minus 6 leaves 1, and 1 minus nothing leaves the 1. Question 2. Work out 2 and 5/6 plus 9 and 1/3. Give your answer as a mixed number. You must show your working. Right. Some people like to add the whole numbers separately and the fractions separately. I find it's handy to keep them all together, so I'm actually going to convert these numbers from mixed numbers into top-heavy fractions. So what I mean by that is, what I'm saying, we've got 2 whole numbers, so to convert this into a top-heavy fraction, we're going to say, well, 2 times 6 is 12, add the 5 is 17, so that's 17/6. Okay, now that's that one. Then we've got 9 and 1/3. So if we want to convert this into a top-heavy fraction or an improper fraction, we're going to say 9 times 3 is 27. Add the 1 is 28. So we've got 28/3. Okay. It might not look like it's helped, but it's got rid of the whole number. Now we've just got 2 fractions. So what we want is 17/6 plus 28/3. Well, the denominators are different, so we can't add them as they are. But 3 goes into 6, and 3 goes into 6 twice. So what we can do with this is double the top and bottom by 2. Okay, so let's do it like this to show that we're doing both of them. So 28 times 2 Well, 2 8s are 16. 2 2s are 4, add the 1 is 5. So if we're doubling the 28, well, why did I put a 1? We get 56. And if we double the 3, we get a 6. So we're saying 28 over 3 is the same as 56 over 6. And the reason we did that is because we've already got our first fraction as being over 6. So that means that now the answer is going to be 6 because the denominator is the same. We just need to add the 17 and the 56 together. 7 plus 6 is 13. 3 carry the 1. 1 plus 5 is 6. Add another 1 is 7. So we've got an answer of 73 over 6. Okay, but they want the answer as a mixed number. So that means we've got to find out what's the whole number? How many times is 6 going to 73? Well, let's do this using the bus stop method. How many times does 6 go into 7? It goes once with 1 left over. And how many times does 6 go into 13? Well, 6, 12, so that's twice. Remainder 1 with 1 left over. So for the actual answer, we've added them together and we found that our answer is 12 and 1, remainder 1, out of 6. So 12 and 1/6. Okay, question 3. Lara wants to join a cycling club. The club website states that the average speed of club rides is 15 miles per hour. Lara goes on a ride to work out her average speed. She rides 60 kilometers in 3 hours. We're told that 1 mile equals 1.6 kilometers. Lara thinks that her average speed is lower than the average speed of club rides. Is she correct? Show why you think this. Okay, so we've got a few bits going on here. Now, the club website states the average speed is 15 miles per hour. So we've got miles and per hour. Lara's ride is in kilometres and for 3 hours. So we want to get everything with similar units. So the first thing we can say is, well, if this is for 3 hours, if we do 60 divided by 3, this will tell us how far she rides in 1 hour. Okay, so let's do this using the bus stop method. 3 goes into 6 twice, 3 goes into 0, 0 times. Okay, so we can say she rides 20 kilometers in 1 hour. Okay, so we've still got kilometers compared to miles, but at least we're dealing with just 1 hour for each one. Okay, well, we can either try and convert her kilometers into miles, or we can convert the miles into kilometers. Because we know 1 mile is 1.6 kilometers, if we're going from miles to kilometers, we're going to multiply by 1.6. If we're going from kilometers to miles, we'd have to divide by 1.6. So I think multiplying by 1.6 is going to be easier. So I'm going to do 15 times, and I'm actually going to make it 16 to start with. And then I'll put my decimal point in afterwards. So 5 times 6, 6, 12, 18, 24, 30. 1 times 6 is 6, plus the 3 is 9. Now we move on to the 1, so we're going to have 0 in the units. 1 times 5 is 5. 1 times 1 is 1. And we're going to add these together. 0 plus 0 is 0. 9 plus 5 is 14. 1 plus 1 is 2. Now we're going to put the decimal point in. So it was 1.6, so we're putting it in 1 decimal place. So that means we need to put it in 1 decimal place on the answer as well. So this 24 actually represents 24 kilometers per hour. Okay, so this has come from up here. Now she thinks her average speed is lower than the average speed of club rides. Well, her average speed was 20, and yes, that is less than 24. So yes, she is correct. And then we've got part B. Show a check of your answer. Okay, well, this is where we can do it the other way round. So, or we can work backwards, in fact. We did 15 times 1.6 to get 24. What we can do if we work backwards is we can say, well, let's do 24 divided by 1.6. Right, well, this is going to be a little bit tricky doing the division because we've got a decimal here. But what I can do is I'm going to increase or multiply both of these by 10. So I'm going to say 24 divided by 1.6 is the same. If I move the decimal point on or multiply by 10, it's the same as 240 divided by 16. Okay, so we've multiplied this by 10 and this by 10. Or in other words, we've moved the decimal point one place or added a 0 here and moved the decimal point one place there. Now, that means when we do our division, 16 into 240, well, 16 doesn't go into 2. 16 into 24, well, it goes once, and how many left over? 17, 18, 19, 20, 21, 22, 23, 24. So that's remainder 8. And then how many times does 16 go into 80? Well, you might need to do some calculations here, but if we try doing it as like the 16 times table, we'd have 16, 32, 48, 64, 80. So that's going to be 5 times. So say you might want to do more workings out than that. But we've got back to 15, which is what we wanted. So we've done a check. And there's going to be other ways you can do a check as well. Okay. Let's have a look at the last question in the non-calculator section, which is question 4. Bart is the manager at a building site. He needs to lay a concrete foundation. The diagram shows the ground space for the concrete foundation. So we've got 24 metres down this way, 27 metres this way. The depth of concrete will be 0.3 metres. Concrete is delivered in concrete mixer trucks. Each mixer truck holds 6 metres cubed of concrete. Leave it up just so we can see the question as well. How many mixer trucks of concrete does Bart need in total for the concrete foundation? Right, we've got 6 marks, so a lot of work here. So just so we can help to picture this, this is almost like a bird's eye view of where they're going to be filling it in. But the depth of the concrete is 0.3 metres, so I'm actually going to sort of draw on this so we can sort of make it look a little bit 3D. So we get a feel for, well, actually it's this little bit here that we're saying is 0.3 metres. Okay, right, so we're going to work out how many mixer trucks we need. Well, to start with, we're going to need to know the volume of this thing, this sort of 3D triangle. And even before that, we're going to need to know the area of this triangle. And we can then multiply it by the depth. Well, the area of a triangle is half times the base times the height. Okay, so that's a half. What's the base? Well, the base is 27. the height is 24. Now, because we're multiplying these, it doesn't matter which order we do the multiplication. Now, doing a multiplication with if we want half of an odd number, for me that feels more difficult than doing half of an even number, especially as it's a non-calculator section. So I'm actually going to do half of 24, or in other words, 24 divided by 2. So 2 goes into 2 once, 2 goes into 4 twice. So half of 24 is 12. So that's these two together. And then we need to multiply it by 27. Okay. So let's do this. We'll do this over here. So 12 times 27. 2 times 7 is 14. 1 times 7 is 7. Add the 1 is 8. So we're moving over to the 10, so we can put a 0 here. 2 times 2 is 4. 2 times 1 is 2. So we need to add these together. So we've got 4 plus 0 is 4. 8 plus 4 is 12. 2 carry the 1. And 2 plus 1 is 3. So we've got 324, and that's going to be meters squared. In fact, let's put that in here. So that's the area of this triangle. Okay, so now we've got the area, we want to work out the volume, so we need to multiply it by the depth. Because if you remember, the volume is the height or length times width times depth. If you think of it like a cuboid, actually no, it's probably better to think of the volume as the area or cross section times the height or the depth. That's probably a better way to think of it. Okay, so if we know the area of the triangle, we multiply it by the 0.3, it'll give the volume. So 324 times, and I'm just going to make it 3 for now. I'm going to leave out the 3 times 4, or 3 4s, you've got 4, 8, 12. 2 carry the 1. 3 2s, 2, 4, 6, add the 1, 7. 3 3s, 3, 6, 9. Okay, 972. This is where we want to put in our decimal point. So we also put the decimal point in the answer. So we've got 97.2. It's now volume, so it's going to be in meters cubed. Right, so we're getting there. That's the volume. Each mixer truck holds 6 meters cubed of concrete. So we're going to need to divide our 97.2 by 6 to know how many trucks we need. Well, 6 goes into 9 once, with 3 left over. 6 into 37, well, we've got 6, 12, 18, 24, 30, 36. That's 6 times with 1 left over. Let's put our decimal point in. And 6 into 12, or 6, 12, that's twice. So we've got 16.2. So 16 trucks won't be enough. We're going to need 17 trucks. Okay, so quite a bit going on there. But we've got a nice logical process. Think of what we have to work out first, get down to here, and then remember, we don't want to round it down to 16 because 16 trucks would be less than that. We have to go for 17 trucks, even though we've only got a little bit for that last 17th truck. And that's the end of the non-calculator section. So now let's have a look at the calculator section. Question 1. Here is a formula. Okay, and we got k equals, and on the top of the fraction we've got 3 and then brackets, which hopefully we know means times, so it's 3 and in brackets u plus 7.15, and all of that is over v. Work out the value of k when u equals 2.9 and v equals 6. Well, let's substitute the values in there. So we're going to have that k is equal to 3, and I'm going to put in my times, but still keep these in the brackets. So u is equal to 2.9 plus 7.15, and all of that is divided by v, which is 6. Now we need to remember our BIDMAS rules now. Anything in brackets is done first. So we're going to add these two together. So we're still going to have the 3 times, but the 2.9 plus the 7.15 means we've now got 10.05. And that's all divided by 6. Now also, because this is on the top of the fraction, it's almost like there's sort of invisible brackets around this as well. So we need to do all of the top first. So if we multiply this by 3, we get 30.15, and that's still divided by 6. Now we divide it by 6, and we get 5.025. Now I've made sure I wrote down every step. You don't have to write every step, but I think it's really helpful, especially if you do make a mistake. This way you'll still get working marks because you've shown that you know what to do, even if you've made a little slip along the way. Question 2. Shona and Erica are gymnasts. Here are the scores Shona got in the last 7 competitions. So she got 12.9, 14.3, 14.1, 13, 13.2, 13.9 and 13.1. Erica only took part in 6 of these competitions and had a mean score of 13.4, a median score of 13.3 and a range of scores of 1.5. Shona thinks on average her scores were better than Erica's scores. Erica does not agree. Explain how Shona and Erica could both be right. You must show your working. So we're talking about mean and median. So we need to work out the mean and median of these numbers for Shona. I'll do the median first. So what I'm going to do is I'm going to rank them. I'm going to put them in order of smallest to largest. So this is the only one starting with a 12, isn't it? So that's one, the smallest. These are 14. These are all 13. So 13.0 would be next. And 13.1. Then 13.2. Then 13.9. Then this is next smallest. Then this one. So if I write those out again, where shall I write them? Let's write them here. So we're going to have 12.9. Then the second one was 13.0. Then 13.1. Then 13.2. Then 13.9. Then 14.1. And finally 14.3. So to work out the median, we cross out the smallest and the largest. Keep going until we've got either 1 or 2 left in the middle. Because we've got an odd number of values, we've just got 1 in the middle. So that's nice and easy. Okay, so we've got the median for Shona. Right, we're not going to do any commenting yet. We're just going to stick with that. Now, we need the mean for Shona as well. Well, the mean is the total divided by how many? Well, the frequency. So we need to add up all these values. So we've got our calculator, so 12.9, add 4, my hand's getting in the way, add 14.3, add 14.1, add 13, add 13.2, add 13.9, add 13.1. So we've got a total of 94.5, and the frequency, well, we've got 7. So our mean is going to be 13.5. Right. So this is Erica. I'm just going to write Shona's values here as well. Well, the mean for Shona is 13.5 and the median for Shona was 13.2. Now they're looking at who's got better scores. Well, the mean for Shona is higher because it's more, but the median for Erica is higher. No, I haven't worked out the range because the range isn't going to tell us about an average. Range is useful if we want to know how consistent or how close together their scores are, then the range would be helpful. But in this question, we don't actually need that, so we can ignore the range. So they've asked us to explain how Shona and Erica could both be correct, and we can say, well, Shona has a higher mean score. Erica has a higher median score. So depending on which average you use, they could both be higher. Question 3. Archie puts an advert for his company online. He has to pay £0.85 or 85p each time someone clicks on his advert. At the end of week 1, Archie pays £650.25p for the total number of clicks on his advert. Archie estimates that each week the total number of clicks on his advert will increase by 20% on the previous week. Archie thinks that in week 3, more than 1,000 people will click on his advert. Is he correct? Right, well, we need to work out how many clicks he had in that first week. And we can do that by using a £650.25. That's how much he made. And he made 85p for each click. So if we divide it by the 0.85, it's going to tell us how many clicks he got. So 650.25 divided by 0.85, and you got 765 clicks, and I'll put in week 1. Okay, so 765. Now each week it will increase by 20%. So we can work out 20% of this and then add it on. And then we can work out 20% of that total and add it on. What I'm going to do is multiply it by 1.2. Because if you remember, 20% is equal to 0.2. So that means 120% is equal to 1.2. So what this is doing is it's not just working out the increase, but it's working out the total that it's increased to. So it's working at 120% of 765. That will give us the total after week 2, which is 918 clicks in week 2. And if we want it for week 3, we'll do the same again, times by 1.2, and we get 1,101.6. Well, whether you can get 0.6 of a click or not, we're not going to worry about that, because all we're worried about is that 1,101.6 is more than 1,000. So we can say yes, he is correct. Question 4. The scatter diagram shows information about the age of patients and the waiting time for these patients to get an appointment. Okay, so we've got the waiting time going up here and the age of the patients going along here. Describe the relationship between the age of patients and the waiting time. Well, you could say there's no correlation because it's a little bit all over the place. But for me, it feels like as the X increases, these values are sort of coming down a bit. So for example, if I was going to put a line of best fit, which they haven't asked for, I'd probably do one, something like that. Okay, so I would say there is a, because the line's sloping down, we've got a negative correlation. But in the mark scheme, they would accept no correlation as well because they are all over the place. But I think there is some negative correlation, which they also accept as a correct answer. Now, for part B, work out the fraction of patients aged over 50 who had a waiting time greater than 30 days. Okay, so we're just interested in the fraction of patients aged over 50. So we want to know the over 50s first of all. So if we bring this back down here. Right, so let's draw a line at 50. So how many over 50s have we got? Well, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so it's going to be out of 9. So this is over 50. And they wanted the fraction of patients aged over 50 who had a waiting time greater than 30 days. Well, this is our waiting time, 30 days. How many are over 30 days? So it's not these three, it's 1, 2, 3, 4, 5, 6. So we've got 6 out of 9. So we can put this in here. If you wanted to, you could simplify that. So you could divide both of these by 3 and simplify it down to 2/3, which would be great, but they haven't asked to simplify it. So you'd get full marks if you put 6/9 or 2/3. Question 5. Kelly works in a grocery shop. She wants to order 120 chocolate eggs. Kelly finds this offer. A box of 30 chocolate eggs, normal price £65, now 16% off the normal price. She thinks she can buy 120 chocolate eggs for less than £200 with this offer. Is Kelly correct? Show why you think this. Right, so we want to buy 120 chocolate eggs. The price is per box. So we want to know how many boxes she needs. Well, we've got 120 to buy, 30 in each box. So 120 divided by 30. We've got 4 boxes. Okay. Now, at this point, we know we've got to take off 16% of the price. We can take it off of the £65 and then multiply it by 4 for 4 boxes, or we can multiply the 65 by 4 to work out the total cost and then take 16% off of that total. Doesn't matter which way round we're going to do it. So what I think I will do is I'll do the 4 times 65 first. Okay, so I've got our 4 from before. So the full or the normal price would be £260. But we've got 16% off. So again, you've got 2 ways of doing this. You can take, if you want 16% off, you can think, well, that's 100 minus 16. So that means that's 84% that I want. So you could do 84% of the 260, which is a nice tidy way of doing it. But what I'm going to do is I'm actually going to work out the 16% first. So a slightly longer way, but I know people quite often prefer this. So 16%, so 16 over 100 times 260 gives us £41.60. It's off, so we need to do the 260 take away, 41.60. So I'm going to put that in my memory. And then say 260 take away, memory recall, gives us 218.4. Well, you can't have 0.4 of a pound, so we've got to make it 40p. She thinks she can buy 120 chocolate eggs for less than 200. Well, 218.4 or 40 is more than 200, so no, she is incorrect. Right, it looks like a blank page, but we have got part B to this question, which is use a reverse calculation to show a check of your answer. So we're going to do that last bit backwards. So we had, what did we have? Well, our final answer was £218.40 or 0.4. We'd taken £41.60 off, so we're going to add 41.60 or 41.6 back on. And if we do that, we get back to I wrote it down wrong, £260. There's our check. Question 6. Abdul is an apprentice architect. He has this diagram of a building. Here we go. So it's got like a big sort of like cuboid at the bottom with this bit of a sort of 3D prism on top. Oh no, prisms are all 3D, so prism on top. Okay, and it says draw the front elevation of this building on the centimetre grid. So we've got all of our measurements here. The front, they're telling us we're looking that way for the front. And we're told to use a scale of 1 to 100. And they've given us this grid down here to use, which they've said is a centimetre grid. So we know that one of these squares is 1 centimetre. But we do need to use that scale, this 1 to 100, because this is all in metres at the moment. But luckily, I know that 1 metre is 100 centimetres. So basically, if we're saying this is 7.5 metres, it's going to be the same as 7.5 centimetres to scale. I'll put scale in brackets. Okay. And it's going to be the same with all these measurements. So we can put 7.5 centimetres, or actually maybe to make it nicer, we can say like 9 boxes, in other words 9 on here. Okay, so the numbers are going to be the same. So actually, that's not too tricky. We've got to start to think about what our view is going to look like though. So we're going to have this big rectangle at the bottom. So if we're looking from this view, we'd see a rectangle here, and we would see this roof, but we wouldn't see the fact that it's sloping, we would just see the maximum height. Okay, so let's draw that box. So we're going to have, actually before we do it on the grid, I'm going to draw a sketch of it. So we're going to have this, we can have a rectangle like this, which is going to be 9 centimetres across and 5.5 centimetres up. And then we'll have this little bit here, which is 3 centimetres wide. And yeah, we're just going to see the height of it. So it's going to be sticking up like that by 2.5 centimetres. So that's my rough sketch. I've got to put that on this grid. And because I've pushed it up, you won't be able to see it anymore. But we know that we've got 9 across the bottom, so 1, 2, 3, 4, 5, 6, 7, 8, 9. To make it a bit more defined so you can see it more clearly. And it was 5.5 squares up, so 1, 2, 3, 4, 5.5. Same over here, 1, 2, 3, 4, 5.5. Again, try and make my line a bit more defined so you can see it better. Now we're still going to have this line going straight across the top. Yep, that's our rectangle, but we're also going to have this bit sticking up here. And that's 2.5 squares, so, well, half, 1, 2. And then we're going to go 3 centimetres across, so 1, 2, 3. And then it should be 1, 2.5 coming down. Now with your pencil, if you're doing this in the exam, it should show up better. I'm doing black on black here, which isn't great. But that's what you need for your scale drawing. Okay. Question 7. The tree diagram shows the probability that an item of clothing selected at random is a skirt or dress and long or short. Complete the probability tree diagram. Okay, so what this is telling us is that the probability of it being a skirt is 0.45. Well, we should know that the total probability always needs to add up to 1. So if there's a 50% chance that it will rain today, there's a 50% chance it won't rain today. So what we need to do to work out this one, we'll do 1 minus the 0.45. Which gives us 0.55 or 0.55. Okay. And we can do the same over here. So this is another independent sort of probability. Once we know that it's a skirt that's been picked, there's a 0.3 probability that it's a long skirt. For the short skirt, it's going to be 1 minus 0.3, which is 0.7. So we've got all our probabilities filled in on there. And then we're told, an item of clothing is chosen at random. Work out the probability that this item is a long skirt. Right, so we want long and we want skirt. Well, this is the long bit and this is the skirt bit. So we need to multiply our two probabilities together. So it's going to be 0.45 times 0.3. Let's move that up there. And you get 0.135. Now, often what people will do is they'll know that they want this probability and they want this probability, but they'll forget that you need to multiply them together. And they might add them together instead. But if you add them together, you get a probability of 0.75. So what you're saying is the probability of getting a long skirt is more than the probability of just getting a skirt, which doesn't make sense. So even though it can be a little bit sort of theoretical sometimes, try and look at your answers and think, what does it actually mean? And that should help you to be able to check if you made a mistake or if you've done something that's looking sensible. So here we're saying 0.45, or there's a 45% chance that it's a skirt, and if it's a skirt, there's a 30% chance that it's long. So a 13.5% chance that it's a long skirt seems sort of sensible. Question 8. Takeshi is the manager at a laboratory. The table shows information about the number of tests done at the laboratory each day in April. So there were between 1 and 10 tests done on 8 days, between 11 and 20 tests done on 14 days, 21 to 30 tests done on 5 days, and 31 to 40 tests done on 3 days, with a total of 30 days. Takeshi expects the mean number of tests done each day in May to be 12.5% greater than the estimated mean number of tests done each day in April. The laboratory is open for 31 days in May. Each test brings an income of £130 for the laboratory. Work out the expected income for the laboratory in May. You must show your working. Right. So, with all of that writing, what have we got to do? We've got to work out the estimated mean number of days. Now, usually when we see estimated, we think we've got to do some kind of rounding. But when we get a question like this, the estimating is the fact that, well, they're telling us the number of tests are between 1 and 10 in this category. So the estimating is that we've got to say, well, I don't know exactly where it is between. So I'm going to assume that it's right bang in the middle. So I'm going to have a new column, which is midpoint. And this is the estimating bit. So what I can do to work out the midpoint is I can take the smallest value, add it to the biggest value, and then divide that by 2. Okay, it seems reasonable. If we don't know how many tests, assume it was right smack bang in the middle. So 11 plus 20, divided by 2, 15.5. Do the same here, 21 plus 30 equals, divided by 2, 5.5, and then 31 plus 40, divided by 2, and we get 35.5. So, if you remember, we're trying to work out the mean, and if you remember, the mean is the total divided by the frequency. Well, if we want to get the total, we've got to get the total per category first of all. Because we were saying, well, now we can kind of ignore these, because instead of 1 to 10, we're saying, well, there were 5.5 tests, and 5.5 tests were done for 8 days. So if we do 8 times 5.5, so we're going to multiply these, we actually get 44. So this column is going to be my frequency times my midpoint. So do the same for this one, 14 times 15.5. 5 times 25.5, and 3 times 35.5. So what that means is when we add all of these up, so I'll start at the bottom as I've already got this one, 106.5, add 127.5, 217, add 44, so we get 495. So that's the total number of tests that were done. Okay, so our mean is 495, and we divide it by how many? Well, we want to know how many per day. Well, we had 30 days, so we're going to divide that by 30. To give us 16.5. Right, now we're trying to work out how much money they make in May. We know we've got 31 days, but we also know that it's going to be 12.5% greater than in April. So we want to increase this by 12.5%. So I'm going to say, well, 12.5%, if I divide it by 100, it's going to turn it into a decimal. Which is 0.125. And then if I add 1 to it, obviously I'm going to get 1.125. And what this is saying is it's 112.5%. So again, what I'm trying to do is I'm trying to include the increase and the original amount all in one calculation. So if I do my 16.5 times 1.125, so we add on the one here, times 16.5, we get 18.5625, and that's tests per day in May. Okay? Right, so that's how many tests there are per day. If we're trying to work out the expected income, well, we're going to be doing 18.5625 tests per day. We've got 31 days, and each test will make us £130. So multiplying these all together. And if we do that, we get 74,806, and it's money, so we want two decimal places, 87, but this is a 5, so we're going to round it up to 88. And there's our answer. So quite an involved question. We've got to work out that estimated mean, but then we've got to do a percentage increase and then a further calculation to work out the total income. Question 9. Jasper organises large events. Last week, 23 workers took 4 hours to build a stage for a concert. Next week, Jasper wants to hire workers to build the same stage in 3 hours. Work out the minimum number of workers needed to build the stage in 3 hours. Right, so let's think, how many hours of work are there in total? Well, if 23 workers were working for 4 hours, so all 23 of them work for those 4 hours, that means we've got a total of 92 hours. That's how much work needs to be done. If we want it all done in 3 hours, we can say 92 divided by 3 gives us 30.66, blah, blah, blah. Okay, so if we had 30 people working, well, 30 people working for 3 hours, it's not going to be enough. They're only going to do 90 hours worth of work. So we're going to have to go up to the next whole number, 31 workers. And if we check that, 31 workers working for 3 hours, well, they'd get 93 hours of work done. We only need 92. So they can have a tea break in there as well. Okay. Question 10. Here is a coordinate grid. Okay. So at the moment we've got our x-axis, we've got our y-axis here, and we've got this line marked on it with A and B. Plot and label the point C at -3, 6. So -3, so we always go across first. Here's -2, here's -4, so -3 would be in the middle. And the y-coordinate is 6. So 2, 4, 6. So this is going to be C up there. Okay. Now we need to look down here. Sylvie wants to draw a trapezium ABCD on the grid. She will use the straight line AB as the base of the trapezium. Sylvie wants the trapezium to have 2 right angles. Plot and label a point D on the grid to complete the trapezium for Sylvie. Right, so we need to get a trapezium on here somewhere. Well, if you remember, trapeziums, they can look different. The key thing with the trapezium is that the top and the base are parallel. So you could have something like that. Now with this one, they've said that we've got to have 2 right angles. So if we're going to have 2 right angles, well, let's assume that we've got one line coming down there. So we've got this sort of thing. What if we have a right angle? Maybe we can put a right angle in here. And then if we connect this at the top, we can have a right angle there. So that means we want our point D to be directly above A and directly along from C. Okay. They've not asked us to draw the trapezium, but I'm going to do it anyway. Okay. They just wanted us to label a point D on the grid, which we've done there. And in fact, we can even draw in our two right angles there. Let's have this up a little bit. There you go. Question 11. Vicky works in a park. She needs to put edging around a lawn in the park. The diagram shows the dimensions of the lawn. The lawn is made up of rectangles. So we can think of it as, well, you could a long one there, one here, and another long one. Or you might think of two short ones and a big long one. But we got rectangles. And we've got all the measurements in feet at the moment. Vicky will buy edging in 5 metre lengths. She can cut and join the lengths of edging. She knows that 1 metre is 3.3 feet. Each length of edging costs £38.99. Vicky has £1,000 to buy the edging. Does Vicky have enough money to buy all the edging she needs? Right, so edging. So we're talking about the outside or the perimeter. Let's put outside. So we need all of the lengths. So I'm going to go with the easy one. If we know this is 63 feet over here, this is the same. So this is also 63 feet. Okay, so I want to make sure I've got all of these measurements before I start adding them up. Okay, and what have we got? If this is 41.5 feet here, this is also going to be 41.5 feet. So we've got this length, this one, this one, this one, this one, this one, this one. The only one that's missing is down here at the bottom. Now we can't assume it's the same as this because we don't know that, but we do know the total is 93.5 feet. And this bit is 50 feet. So actually I'm going to draw that in. So this is 50 feet. So if we think of these two together, so this all the way along here, we're going to have 50 plus 23.5 which is 73.5 feet. So this is going to be the difference between the full length, so in other words it's going to be 93.5, all of this, minus this bit here, so minus the 73.5 feet. So I can put that in the calculator, so 93.5 minus the 73.5, so this is 20 feet here. Right, so now we can start adding everything up. So the perimeter is going to be, well, it's always good to mark somewhere so you know where you're starting so that you don't forget. So I'll write them all out so we don't miss any. So we're going to have 63, then we're going to have 93.5. Let's make sure we can see it all. Then we're going to have another 63. Then we're going to have our 23.5. Then we're going to have 41.5. I'll go down here. Then we're going to have 50 feet along. Then another 41.5. And finally the 20 feet to get us back to the beginning. Okay, so let's see what we get if we add that all together. So 63 plus 93.5 plus 63 plus 23.5 plus 41.5 plus 50 plus 41.5 plus 20. and we get a total of 396 feet. Okay, so we got the feet. But the edging comes in meters, so we need to turn this into meters. Right, well, if we know that 1 meter is 396 feet, we're going to need to have 396 divided by 3.3. That's going to tell us how many meters we've got. And we get a nice round 120 meters. Okay. The edging is in 5 meter lengths. Okay, so we've got to have 120 divided by 5 now to tell us how many lengths. So we've got 24 lengths. Okay, and each length is £38.99. So we've got 24 times £38.99. Which is 935.76. And does Vicky have enough to buy all the edging? Well, she's got £1,000. That's less than £1,000. So we can say yes. She has enough. And now we're on to question 12. Write as a number 7,430,900. So 7,430,000. So 430,900. Up for the next bit. Dorothy reads an article about a talent show. The article states that 17,424 people applied to enter the show last year. Each person that applied was either a singer or a dancer. The ratio of the number of singers to the number of dancers was 3 to 5. This year, 19,500 people applied to enter the show. 39% of these people were singers. Dorothy thinks that at least 1,200 more singers applied to enter the show this year than last year. Is she correct? Right. Lots going on. So what do we want to start with? Well, we're looking at the number of singers. So what we can do is we can use our ratio here to find out how many singers there are. So it's a ratio question. Let's draw a little table. And we're going to have singers, dancers, and we'll have a total. So the ratio is 3 singers to 5 dancers. So if we had 3 singers and 5 dancers, we would have 8 in total. In fact, we had 17,424 in total. So we want to know how can we get from this line down to this line. So what we're going to do is 17,424 divided by 8. And that gives us 2,178. So what we're saying is that you multiply that by 2,178 to get down to this line here. Now, if we want to find out the number of singers, well, we just need to multiply that by the same number. So we've got that in there, multiplied by 3. So we're saying there were 6,534 singers. Okay, right, now, that's how many there were last year. Okay. This year, 19,500 people entered the show, and 39% of these were singers. So this year we've got, let's do it up here, 39%. So 39 out of 100 times 19,500. 39 out of 100 times 19,500 is 7,605 singers, and that's this year. Dorothy thinks that at least 1,200 more singers applied to enter the show this year than last year. Well, we can check that. So we can say 7,605 from this year minus 6,534 from last year is 1,071 singers. Well, 1,071 is less than 1,200, so is she correct? No. She isn't correct. And that's the end of the paper. So I hope you found it helpful. Please like, subscribe to the channel, ask any questions you've got. Make sure your notifications are on to get updates when I load more videos. And I hope to see you all again soon. Thank you.